Right. So thank you everybody for joining this call. I'll try to be very, very brief with my part of the introduction and have a bulk of this for Zahoor to talk through things on his end. Let me know if the screen share is working. Not yet, right? Okay. Yeah, so at a very high level, folks, Archimedes is a software engineering guild. It was called a guild before the word guild became popular in sort of Web3 circles. So I'm proud of the fact that we were maybe a little bit ahead of the curve on that. But at a very high level, we are really focused on two things. One, we are focused on helping engineers connect with each other and foster a sense of community, really, in a world that you don't work in one company for more than a few years anymore. And the idea behind Archimedes is to give you a place that you can belong to for a much longer period of time than that. The other part of it is to enable you to grow and get better at what you want to get better at, and the third piece of it is to enable you to basically make good income through various different income streams. I'm hearing a lot of background noise. I may have to mute someone. Just checking who it might be. All right. So yeah, in terms of how the guild works, when people come into the guild, when you basically first off have to be an engineer to apply to the guild. Once you apply to the guild, you get banded at a certain level that happens through a guild screening process. So the guild itself generally screens who comes into the guild. We don't really get very involved in that process as the core team that manages Archimedes. And we are basically created by a whole bunch of folks with really a lot of deep experience on the enterprise side of things. John, myself, both are ex-Accenture. Aman, who may not be on this call, he's ex-IBM. We have a whole bunch of ex-ThoughtWorkers helping us with various parts of the guild screening process and things like that. So a lot of the DNA of the guild in some sense is either ex-Accenture, IBM, or ThoughtWorks for some context. And the Engineering Mastermind essentially are our showcase to the outside world as well as to guild members to some degree, where we talk about key topic areas that might be of interest to people within the guild. We did a mastermind last month with Joel Dice. I'm not sure if he's on this call, but it's really, really good. You can watch it on YouTube on the Archimedes channel, where we talked about web applications and building web applications with Rust and WebAssembly. And of course, this week's talk is by Zahoor. We're really, really happy to have him. He helped build Ethereum Swarm as part of with the Ethereum Foundation, and now he's helping build out ETH2 as part of Prismatic Labs. So he's been plugged into this community for a while now, and is honestly at the precipice of something really big with what's being planned out for ETH2 in the very near future. That said, I'm not going to take more time than this. If anyone's interested in learning more about the guild, either how you can join the guild or how you can potentially work with the guild, because there are ways for companies and startups, etc., to work with the guild, then you can reach out to me directly via email or connect to me through LinkedIn, and we can talk. But that said, I'm going to pass it on to Zahoor, who hopefully will spend a bulk of this conversation on educating all of us in terms of where things are headed with Ethereum, Web3, and all of the things that we're also interested in.
Hey, Sadiq, thank you very much for the introduction. Yeah, thank you very much for the introduction. Let me see if I can share my this is the problem if you have multiple browsers opened up. Yeah, can you see my slides?
Yep, perfect.
Okay, So today I'm going to talk about something we would, some people might have actually heard about it. They would have done some research on it. Some people might be actually working on it. Some people might have no idea about it. Some people, might have seen like too many, buzzwords surrounding this, and they are like ignoring it as it's like something something stupid or something like that, so okay, I mean, in actually today's talk, I'm not going to actually teach you much. What I'm going to give you is that I'm going to give pointers for you to go back and do your research if you want, right? So this is like, I mean, a mixed audience. So I would actually start from the beginning. And if like some people are already introduced to all these things, excuse me, okay? Because I can't help it, because I need to give context for people.
Zahoor, would it be
Okay.
possible to go full screen? I think if you go to slide, yeah.
I'm doing it. Yeah, I'm doing
Thank
it.
you.
So yeah, so a little bit about myself. Who's this guy? Zahoor. Jmoza is my usual handle. GitHub and all these places, except Twitter, because I created that long back. I've been coding for 25 years. Was in telecom, big data, data science, payments, and somewhere around 2016, I got into this, this thing called blockchain, rabbit hole, and then started contributing to some projects, and then eventually got hired and went full time into this from 2017. I worked in Ethereum Foundation. I worked in Swarm Foundation. I built something called as Swarm. If some people have heard about IPFS, this is very similar to that, but much more sophisticated and actually complete system. This was actually part of the initial 3 pillars that Ethereum actually wanted to build. They wanted to build Ethereum consensus engine, which is the Ethereum that we know today. They want to build Ethereum Swarm. They want to build Ethereum Swarm is to store decentralized information, to actually store the information in a very decentralized fashion. And then they wanted to build something called as Whisper, which was to do communication, to actually communicate over the internet in this fashion, according to actually the rules that have been set. I mean, actually, the basic tenet of all these things is like, okay, so yeah, okay, so I'll come to that. Okay, so and then I'm right now working in Prismatic Labs. That's creating a client called Prism, which is the 2.0. I don't know how many have heard about this, and yeah, this is how I was before going into blockchain, and this is how I became after I went into blockchain. Okay, so a little bit of context. What is Web 1? Web 1, if you are like in this if you are actually like go 20 years back or something like that, when internet came through, if you want to actually put a blog, you actually create your own machine. You just go and buy the ISDN network that you want, backbone, internet network, and then you also buy all the hardware, everything, and then you actually get a software that can create a blog, and then you say, this is my blog, and the world people comes and looks into this. Let's say it has 2 cores, 4 GB RAM, whatever it is, right? So this was like super good, right? So anybody can publish anything, and it was like fantastic. This is internet, right? Okay, internet gives me power, right? Now I don't want to just actually listen to somebody's broadcast, but I can broadcast my own own thinking, right? In terms of writing and then in terms of videos and all these things. Now, the problem with Web1 was like, let's say if your blog becomes suddenly put into some, very high popular site, today's Hacker News, for example, right? Then suddenly a lot of people will actually click that and then people will come to your blog. Now that's where the problem comes in. Now you don't have the capacity to actually do stuff and your system actually fails, right? So a lot of people will get 404 or your website is not available, internal error, a lot of all this kinds of stuff. That was the problem. So here, one good thing you had is that you own all the data was with you. But the problem is that you don't have the capacity or this thing to increase it, right? Or you don't have the expertise to do that, even if you have it. And then came actually a Web2, which is like the centralized model. So yeah, I have put this picture in the center. This is something I actually really wore in my T-shirt for DevCon 5, saying that these are evil. These are the evil guys, right? Why am I calling this evil? So they initially came with the promise that, oh, you don't have to host your own stuff. We will do it for you for free and all these kinds of nice things. And then once they have the power, once they have the people, everybody sees that, wow, they don't have to do anything. Just go and then just sign up. I get an email. In actually Web1, I have to create a web server of my own and actually use a program called SendMail. I don't know how many people know that, if you are an old guy like me, so you might remember doing that, all things yourself, your own mail server, your own blog server, your own stuff and all these kinds of things, right? But then Web2 gave this promise of, no, we can actually do this like elastic capacity, management and all these things. If you come to my site and host something, if you come to my this thing and open a email account, or if you open other account, I will give you enough capacity so that you could do stuff, right? That's how all these guys started. And then everybody threw out their old hardwares, and then everybody started to do this. This is very good. I'm not saying this is bad. This is good. A lot of business came through, innovations came through. Today's entire SaaS model works on this. Entire SaaS playbook is something like this. You have a centralized server or like a set of server usually, but a centralized like a website which can do something for you, given you give the proper inputs and things like that, right? So yeah, so okay, what is the problem with that? Over time, initially it was fine for people. Okay, free email, everything free, like communication tool like Facebook. I can find my school friend and all these good things. Everybody was praising, and then finally one day people realized that all these guys are earning a lot by selling our data. Our data becomes now suddenly people have started looking at the data. Okay, this is my data, and he's actually selling the data, and I'm not getting a cut out of that, right? So this is really bad. Number one, you should not sell or extract or do anything on anything about the data without the user's knowledge. Of course, there is terms and conditions that you don't read, but it became so complicated. They made it complicated for you to do all these things. You click accept, and then you are suddenly signing up to sell your data to so many people, and you don't even know where your data ends up, right? Yeah, so I think people remember Cambridge Analytica, what it did, and what is the impact it can cause. It can cause the world's largest democracy. I mean, it can cause I mean, it can actually, you know, change the face of the world. I mean, if you actually select the wrong president, the president was selected using techniques that these guys are using, then it's wrong, right? So that is the problem we slowly found out. There are new rules coming up, but I think people actually at the end eventually has to stand up for this. For example, in Europe, there is a rule for, there is something called a GDPR. If you ask your data, you have to delete your data and give your data to me. But they're making it so difficult to delete a Facebook account nowadays that it's almost impossible to delete a Facebook account without doing so many clicks and doing so many steps, right? So this is the problem with Web 2. Web 2 initially was nice, everything was good, but the problem is centralization, right? What happens when you give power, like too much, like power to somebody? Okay, then it depends on the person, right? The person is good, fine. If the king is bad, okay, why did a lot of people went into revolution? Democracy is good because we don't actually depend on somebody, one king for the entire lifetime, right? So this kinds of argument, I can speak on this slide for 2 hours, but I'm going to go. So all these guys, what they do is that they actually take your traffic. They initially have a large pool of servers. I don't want to go into, I think you guys know all these things. You guys are web guys. So they have a large pool of servers and they have some data stores. Now, the important thing I'm coming is actually data store, because that's where they actually store stuff. Usually they use some kind of consensus model. It's like hundreds and thousands of servers. It's not one. So they have some kind of consensus model, which will say where your data is sitting and how to fetch it and things like that. If you take like open source stuff like Hadoop HDFS and all these things, which is actually based on the big table in Google, this is based on some leader election, and leaders will have like like another a copy and all these kinds of stuff. And there is this thing called where you actually don't you actually go and select your leader like dynamically, right? So okay, so the issue with all these things is that it's beautiful technology, and I like this. I worked on this for a long time, but the problem is all these things are confined to they all assume that either a node is good and actually working fine, or the node is down, right? If the let's say in Cassandra, if a node is down, right, other nodes will actually find out, and they will actually split the keys of these node into the adjacent nodes, and they will start serving that, right? So that's what it will happen. But what if this server is not under your control? That means that you can have like some servers which are which might act in some fashion. It is up, but it is not acting good. It's malicious, right? So if you want to do something like this over the internet, then there might be malicious actors, and you have to do a different kind of consensus. Also, the consensus of these kinds of systems are like they are very tightly coupled. They need high-speed networks. They need all these kinds of stuff. They are controlled by one organization. They know what to do exactly. They know how to install it. They know how to do it. All these kinds of stuff. If you want to do it yourself, it takes some time, and everything is actually in-house, right? You don't say that, okay, half of the servers in my like companies in my bank's cluster is in internet. You don't say that. right? It belongs to you, or you go to a cloud provider and you put a VPN, you put firewalls and all these things, and then do these things. Okay, so I don't want to speak about consistent hashing. This is the technique that they use in like Cassandra and Dynamo and all these places. So it's basically that, right? So then came this, okay, this now I want to do it over the internet, right? Not on the like, I don't want to do it only in my system. I want to do it, across the world, a system which runs across the world, right? Not only in my in-house servers. Anybody can actually spin up a server and can do whatever they want, and it joins the network and it does something, right? The first, there is some noise thing. Yeah. So yeah, so
Yeah,
so I
anyone
think
not speaking, just mute, please,
okay.
if that's okay.
Yeah, please. Yeah, I would appreciate that. Thank you. So this peer-to-peer, the first model that came is this, this BitTorrent, right? This is beautiful system, right? This is like it actually try to download your file from multiple places, multiple peers. It actually goes and gets the peers and knows which blocks to get and all these things. It splits the file, so the file is across. So what you are doing is that you are basically utilizing your entire download bandwidth, and you are using your upload bandwidth to help somebody else. So this is like a system. I mean, it has like two problems. Number one, you still have to run some web server which can have like a file which says what are the different parts of the of the file that you want to download, and you usually run a tracker system which actually tracks which node is up, down, and has what, and is doing what kind of stuff, right? So this is, I would say, this is somewhat centralized, right? Because if you take down this web server, or if you take down the tracker, this one will not work, because your system, as soon as you say I want to download this particular movie, so it goes to the tracker finds out who else has this movie, and then it first actually goes to the torrent to this thing, and then it actually downloads the metadata, and then it says that this is the thing that we need, and it actually goes to the peers and asks who has all these things. It actually maintains a list of stuff, who has what, and then finally it asks these guys to actually serve them, and then it gives the addresses back to the peer, and this peer starts to connect with them and ask for blocks, right? So this is somewhat centralized stuff, right? But it is peer-to-peer. It's like okay, it's like very close to being like censorship resistant, but it is possible to resist this. If a government says that okay, they will not allow torrent to run web servers in their jurisdiction, they can go and cease and desist and do whatever they want, like they did with Pirate Bay or whatever it is, like, right? So yeah, you get the idea, right? So it's still centralized. I mean, any actor who is a person or an organization or or a government or an agency can actually, if it can censor this network, that's bad, right? I mean, then every government will act in their own actually benefit. So if you want really like free speech across the world and then do censorship resistant stuff, you need something else. You need the same peer-to-peer thing, but you don't want this, what do you call, centralized actors that can be targeted and then brought down, right? So then, like these things were there already in like academia. So then there is like a thing called, you can still create a peer-to-peer network, it's totally decentralized. There is no single, all the nodes are exactly having the same power. So it's not like one node is like superior or one node is down or anything like that. Every node acts on the, like a set of rules, and they go and connect with the other nodes and can do something, right? So this base layer, this is the base layer, right? So this is the what do you call the decentralized peer-to-peer systems. If you want to learn more about it, go and search for Kadamlia, right? Kadamlia is a way to actually go and form such networks which are peer-to-peer, and I don't have to actually have to know the knowledge of the entire network. Instead, I only care about my peers, and I only speak with my peers, and they speak with their peers, and they speak with their peers, and so on, right? So if you want to send a message from a peer A to peer B, you should have some protocol built on top of it, which can actually forward the message to that particular node. Every node will have a unique ID. So you can say that from, I am actually node ID 1, I want to send a message to node ID 10, which is actually not in my peer list. I'm actually connected only to 2, 3, and 4. So I send a message saying that, hey, please give this message to 10. I will see who is closer to 10. So there are other things like, the XOR based distance calculation and all these things. But I don't want to go into details, but it's just to say that this is purely decentralized system. Now you could build any, so this is like, you can think of like, you can actually think of like the, a sort of decentralized, you can think of this like actually a base for building anything decentralized, right? And then you can write protocols on top of it, where you actually communicate like you do in HTTP or TCP/IP. You say that, hey, give me that, give me this, give me that, give me this. You can write protocols, all sorts of protocols on top of this, right? So this is how like purely decentralized system. Why I am calling it purely decentralized? So if you can take down like actually an actor in that, a node in that, system is still running, system is still, it's up, right? If you take out if you take out more, it will still be up. It depends on the the rules, protocols, and all these things. How much can the network tolerate a failure until until actually the protocol stops, right? But they'll still be connected with the peer and things like that, right? So it's the base. Assume that this is the base on which I'm going to build all these things. Then came this beautiful stuff, right? That this guy actually started to write. So the first application or the first protocol that was written on top of it was something we all know as Bitcoin, right? So Bitcoin is actually a sort of a protocol, a set of actually rules in the software that is embedded, that is actually installed in every system that runs this, right? Now, actually the rules of the game is that, okay, so like, is there anybody who I want to elect as a leader or anything like that? No. So application is like, if you want to send money from one place to another place, how to do that without avoiding double spending and all these things, right? I'll give you an example of what is double spending. If I have an MP3 file, if I actually attach the file in the email and actually send it to you, now I have the MP3 file and you also have the MP3 file. So this is not good for money. if I have like $5, I give them $5 to you, then I should not have the $5 and you should have that $5, right? So it should be like that. And in internet, you could not do that before this, right? So this set of the rules that actually the Bitcoin, the Bitcoin, this thing, what do you call, the protocol, which actually put down the stuff. It said that if you follow these rules, that means that, okay, that means I can actually send money from one node to another node, or like one address to another address, and all this stuff, right? And that's how blockchain was born. And if you have any question, please stop me and ask any questions, right? I will give some time at the end to do questions, but you can actually stop me if you have something really urgent or else. So this is blockchain. I don't want to go into much detail about all these things because I think we don't have really don't have time. So you can assume this as like a set of rules. I can write any application like that on top of this actual peer-to-peer network, and I can say install this in your nodes, and if enough people install that, there will be a network and everybody will follow the same rule, and then the things will happen. And if you have a malicious user, so it has way to find out cryptographically that this guy is actually not sending it properly, because it actually stores the information in all the nodes. That's how Bitcoin does this. The rule of the Bitcoin is every transaction needs to be stored in all the nodes. So, okay, I'll give an example. I think this is very important. Let's say there are actually, five people who are going for dinner or something like that. And like you get the bill. And then you actually say that, hey, let's split the bill. No, let's split it as we ate, because I ate only, vegan and you ate something. So I don't want to pay for you. I want to pay only for me and things like that. So now all these five people saw what everybody ate. And if a guy says that, no, I didn't eat this dish at all, then other guy can say, all four can say, no, we saw you eating this, right? So that's the crux, right? So if you have like malicious nodes, 1, 2, 3, 4, how many malicious nodes? If you have like 100 servers, the assumption is that you have 51% good people in the network, right? So 49% of the people can say, can give wrong information, but the other 51 has the majority. They say no, we know this is the cryptographic proof for that you ate this, all these things, and they can actually do something, right? So this is the basis of any blockchain, right? This is how all blockchains work, right? So they create the transactions together, they wait for some time and create a block, cryptographically sign, and then you create another block, and then you put the parents hash in this. I think you would actually read that in any blog that will actually tell that. Now I'm going slowly to Ethereum that is there today. So Ethereum, what you do is, okay, now you actually have this, this nice thing on the top. If you look at the Ethereum, what we have today, it has an execution engine, which is called EVM, which actually works on the entire data, the entire blockchain, right? The blockchain data, because it knows the state. It has to know the state. It has to know the receipt that it has been received by the network, all this kinds of stuff. So it actually has this, and all this is actually only execution, right? But you have something on top called like proof of work. That's like a fancy name for doing consensus across internet, right? If you have like 50,000 nodes running across internet, and if I have to, select who is going to actually create the next block, because the guy who creates a block gets some some incentivization. So there are like plethora of guys who will try to actually create block, but I have to select only one guy to say that, okay, this is the block I'm accepting next. Rest of the guys, sorry, go and please try hard, right? So this is the consensus algorithm. I don't want to go into proof of work. You'll find tons of materials about proof of work, how it works and things like that. So right now, Ethereum and actually Bitcoin and all these things work on proof of work. Proof of work means every node will have a miner or something. Not every node, a node which wants to get incentivized will have a miner. Miner is something, initially it was CPU, then it became GPU, then now it's like special stuff to actually mine things. It's just a cryptographic thing that you cannot solve. You can only solve by doing brute force. And for doing brute force, you have to spend some CPU or energy, right? That's what it is, right? It's proof of work, right? So that's how it is today, right? And so yeah, how it's actually what's actually Web3, right? So I mean, like if you look on the top, right, the things that I've colored, right? So that's the playbook of any SaaS application right now. Anything Web2 will be like this. You will have a front end, right, where you will have some like static JavaScript, HTML, and all these things that will speak to a backend, which will have a logic and all these things, and then which will store the state in some kind of DB, right? If it is a very small application, DB can be MySQL, whatever it is, and backend can be as simple as PHP or whatever it is. And then the front end can be plain HTML with JavaScript, whatever it is. And if it's like a complex application, like let's say Gmail or whatever it is, so you still have a front end, you will still have a back end, but you will have like plethora of servers which will split the work and do it. And then you will still have a DB, or I would call it data store than DB, because you just store there, right? Because like DB has some baggage associated with it. And like all these things, when I say DB of like big things, they are actually NoSQL DBs. So they we usually don't call DBs for NoSQL. They are data stores. So they have some kind of like internal clustering and things like that. Now, what will happen? So I mean, in Gen 1, in like first gen, the actual this thing looked like this. Like you will have, I mean, a front end here. I don't know whether you can see my cursor. Can you see my cursor, guys? Anybody?
Yes.
Yes, we can.
Okay. So the thing here in actually the bottom is like the Gen 1, the first generation of front ends of like Web3 applications. We call it I mean, like instead of apps we call it dApps, right? Decentralized applications. Now, what do they decentralize? They still have a similar front end, right? And most of them they still have some non-important logic which can be centralized to do in the backend. This is optional, and they store in some traditional DB related stuff. But what they use blockchain for is to store something which they want to actually decentralize. Let's say, or like this is optional. So there you'll only find a front end, and you will find that the actually front end has a JavaScript that will speak with the blockchain and get information like, hey, let's say if actually the front end is actually a wallet, so it will speak to the blockchain. I mean, it will not have any other stuff here. It will just have this line here. It will speak to the blockchain and will actually get your balance and will show the balance here. And if you want to create a new wallet, it will create a new wallet. And then it will, if you want to send a transaction, you will do something and then you will actually call the blockchain. The blockchain will actually propagate the transaction across to the network. And then you will get back the confirmation from the blockchain that your transaction is either successful or not successful, and you will show in the front end. This is a simple front end. But if you want to build a complex application like where you want to store things and you want to store stuff, people are still using the traditional like backend along with blockchain to store like things that are not really need to be decentralized, right? Like let's say if it has like let's say identity, right? So identity is one thing that people still use username, passwords. Let's say you want to actually store that in some DB and only then allow this access to blockchain. People are doing all these things in Gen 1, right? What actually happened in Gen 2 is that, or like most of this is called fully decentralized applications, right? So you actually don't even use the actually DNS, right? To resolve your website name. You actually go to ENS, which is actually part of the blockchain in Ethereum blockchain, Ethereum naming service. So it has a decentralized way of actually storing some information. Given this name, you give this information, right? That information can be actually a hash. A hash can be it's like your MD5 hash, but in Ethereum and other cryptographic other blockchain thing, you use something slightly sophisticated, which is at least 32 bytes, just 256 bits. For example, Ethereum uses a keycap 256 and things like that. So it's like some hash. But the important thing is that you have a decentralized data store now. Again, DB is actually a wrong word. You have decentralized data store. Now you have you have written this exact peer-to-peer. You have taken the exact peer-to-peer mechanism, the same underlying stuff, and then you built a protocol such that it can store your information in a decentralized fashion. Let's say you want to upload a file or something like that, right? So when you upload a file to a decentralized store, what it does is that it actually stores it in multiple places. It's not in one single place. Nobody knows where it is. And based on actually the routing, it actually tries to fetch the file when you access it, and then it actually gives back to you, right? So what you will do is that you will eventually, what you will do is that you will actually create a front end with all the HTML and JavaScript and all the stuff that you want to do. You will upload that into a decentralized data store, and like that will give you a hash, right? Which uniquely will try to find everything inside this, right? So let's say all static files, all JavaScript files, all like HTML files, entire front-end bundle, right? You just upload it here, you get one Merkle root, which is actually a hash, and then you store the hash in ENS. Now, when somebody calls my app.eth, ENS will give me, so first it will go to ENS, give me this decentralized DB, and it will actually get the files from the decentralized DB to actually the browser. So these files are the files that you will get when you do an HTTP request. right? It's the same HTML files. So your browser will actually render them, right? So you could store the entire front end itself in a decentralized fashion. And then you could store, business logic in the chain, and any decentralized stuff in the chain, and any other stuff, right? An app can store a lot of other things, right? It can be stored in a decentralized data store and can be fetched every time. So there are, okay, again, people will ask, how can I store a decentralized DB, right? So it's like, again, a huge topic. It's very similar to blockchain, uses the same thing. And in fact, decentralized DBs use internally blockchain to incentivize and de-incentivize people who actually give me storage space, right, to store. Let's say I have like 500 GB free. I will go and add myself into this network and will kind of actually go and rent my 500 GB to the decentralized store. And what is getting stored there is actually pieces of encrypted information that nobody will be able to decrypt except the guy who knows the private key of all these things, which is you, right? So you have to write an app which can take this, and if you actually go and sign, if your signature is correct, then that means you know the private key, and it can just actually display all these things. Now, so today's browser, they don't support this. Brave supports IPFS hash and other things. ENS is still supported. ENS, it can actually resolve to something, but if ENS actually has an IPFS hash, I think it will take the IPFS hash, go to IPFS, and actually fetch this stuff from IPFS and display. Another another thing that okay, IPFS is like another parallel system that people built. So what like I and others were building was actually Swarm, which is also very similar, but is more connected and more this thing. I don't want to go much deeper into that. So let's say that it's decentralized, and then it will actually look like this. So now you don't have any backend. You do all the logic that you want to do close to the user in the front end, and you want to store any critical stuff, right? Like like actually moving money from here to this wallet to that wallet to this to that, all these kinds of stuff, the critical stuff inside this blockchain. So you write something called a smart contracts. There is it's think of it like another programming language that will be executed by EVM, something like how Java is executed with executed inside actually the JVM. So it'll get executed, and based on the rules, if the rules are okay according to the protocol, it will actually try to do something, and that will be like permanently stored in the chain, right? So this is how this next generation Web2 looks like. I want to give you a small this thing about
Zahir,
yeah.
Zahoor, quick question on that. This is where, thank you. This is great information so far. Wonderful. Very quick question I have on this slide is regarding the decentralized data store. With this DDS behaving very equivalent to Bitcoin, kind of a concept, right? I just want to give and understand your thoughts on the performance of these DDS when we are making a call from the front end, because anything that is stored in DDS is also synchronized and replicated with other decentralized data stores and things like that. How is the performance is going to be when we're talking about, a lot of transactions to that can happen through the front end, if it is possible?
Yeah, I understand this. So like, okay, so this is actually a very good question, right? So okay, in the front end, I have this nice DB that is like response to me in like, like 2 milliseconds. Will I get the, exact same performance? No, right? So you will not get exact same performance. It will be slightly low. But I think there is a lot of research on how to do routing and caching and all these kinds of other stuff that can be done in between to incentivize, guys who can actually not go until the end where you have really stored your data. But if somebody knows that you will actually use these kinds of data, they will actually cache it on the way, and you access next time, it will be really fast, right? And there are other ways, like, you can have a node, like let's say you are actually running a front end. You can also actually connect to your own node, local node. And if you have like really time sensitive stuff, right? Like I want to get it like this. So you could actually pin them, right? You can actually pin them to your thing, what you call local node, and it will be served from your local node also. So yeah, so it's actually a mix of both, and you have to like as in DB, right? Like you have like you have the if you want to write a serious application using Oracle or anything like that, really big, you want to store terabyte stuff with like if you want to store like like too many things, you have DBAs who actually analyze your what is your this thing, what do you call it, read characteristics, what is your write characteristics of the application. Based on that, they will create index certain fields, they will index certain columns, they might create views to create reports and all these kinds of stuff, right? So you have to do like something very similar to that, but not exactly I mean, what do you call I won't call DB performance tuning, but you actually have to know where to store things, right? You can either store in the front end itself if it actually belongs to a user. If you want that to be available in multiple machines or anything like that, that you can actually store here in the node, decentralized DB. So these are actually fast systems, right? So, okay, so I explained about this thing, right? What do you call, I explained about P2P centralized BitTorrent, right? So, the way BitTorrent works is also very similar, but it is very slow start. You know why? Because it has to go and start the discovery. Every time you ask for a file, it has to go and start the discovery, find out the nodes, connect with them, do all sorts of stuff and things like that. Here, it's up and running and it's already connected to the peer. It just has to ask the peer, hey, you go and get me this information. It might be like, like 2 hops or 3 hops and you will get the information, right? So, yeah, I mean, to answer your question, yes, there would be a slight this thing. I mean, you can't write, of course, you can't write. I mean, like, yeah, as I said to a lot of people, they actually come to me and say, hey, I want to convert my entire Web2 app into, blockchain. I said, why? I will ask why, right? Because, if you want to do, blockchain is something, right? It's like a mediator. You have to first identify what kind of applications actually require blockchain. So there is actually no harm in doing this also, unless you put the critical logic here. Let's say I'm building an Amazon like system, right? So people can actually connect to me, like I can see, I can do all this stuff. So I can still use the same, the same architecture. I can have backends, I can have DBs where I store images and all these kinds of stuff. And I can use blockchain only to, like transfer the money once it has actually reached here and there. Now you will ask me, how do I know that it has reached there in actually physical thing? That's actually most of the protocol work, the game theory, right? So So there is an example. Let's say if you want to build a decentralized Uber, so actually the taxi man also pays 100 rupees deposit. I also pay 100 rupees deposit, and then at the end, so we both agree that yeah, I have done the this thing. You say yes, I say yes, and my 100 rupees actually goes to him until that my 100 rupees that I have put is actually blocked, right? You can't take it unless you both come to some conclusion and things like that. So this is game theory mostly, right? So you have to use like these kinds of stuff to actually do this. So mostly use case of the blockchain is that if you want to avoid any middleman, right, who is doing like certain things that is important, right, like actually like transferring money or whatever it is, right, you can still write using this model also. There is nothing actually wrong in that, but it won't be totally decentralized. This can be, you have to actually know that this can be censored by a government, by an organization like Amazon if you're using AWS, or Google if you are using Google Cloud, whatever it is. But if you are doing like this, right, all of these things are censorship resistant. ENS is censorship resistant. Blockchain is censorship resistance. What does that mean is that, let's say I have like an app where I create something like WikiLeaks that I don't want any government to take down, right? I can create a WikiLeaks and store the big documents here, and like and like if you ask anything here, so it just goes and gets only this and actually gives you the entire wiki. This actually happened. I mean, not for WikiLeaks. When Iran blocked Wikipedia, the entire Wikipedia was put into IPFS, and all Iranians were able to use IPFS. Iran was not able to stop it, right? So yeah, so it's actually that powerful.
Oh,
It's
thank you.
censorship resistance and this, what do you call it? The mediation, the core mediation, the logic that you want to put, that is what, that is when you have to use blockchain, right? I mean, like if you just wants to actually, like create like a normal Gmail clone, you can go and write in Web2, nobody stops you, right? But if you want to write an email application which is censorship resistance, nobody can actually look into my email, nobody can actually do anything on that. Let's say I write an email, I let's say I write a Gen 2 email, right, like Web3 email system. So you have like Zahoor mail or like my email.eth, and then you go there. So if it's the first time, it'll go and fetch all the static and all these things. It'll go and display stuff for you, and then you can say that, okay, if you want to like send any email to let's say Zahoor.eth, right? So it can be an address also. I can actually point to my address also. So my email address can be Zahoor.eth. So I want to actually send an email to Zahoor.eth. So I can actually send it, but I have to spend a small amount of money, right? Let's say if you do this, you will not have spam, right? And you will have like totally encrypted, decentralized, censorship resistance, I mean, email system in the world that, that actually is actually yours, right? So here now, I mean, you can actually allow them to go for a particular user, allow them to go and say that, hey, give me my data, right? So it can actually fetch from the decentralized DB and say, these are the hashes, and you can go to the decentralized DB and using your private key, delete those hashes. And then your entire Gmail data is gone, or like whatever email data is gone. Boom, you have control over your data, right? So this is, I mean, I would say this is the kind of apps that actually should be written in blockchain, right? Of course, you will see a lot of finance related apps, because those are some things that, let's say, so they have like people who have built lending and borrowing and things like that. Let's say I have like 10 bitcoins. I need some money, but Bitcoin is going like low, very low. It's the bear market. I know that it will come up, but I need some money to do something else to pay my bills. I can actually go there, go to the lending app, which is actually written in the smart contract here, and you have only front end. You don't have a DB, you don't have anything else. You have a front end, and then you have a blockchain app, right? So you go and say that, okay, I actually give my 10 Bitcoin as collateral, and I want to get like let's say 10,000 USDT. And you can take that USDT to the exchange and convert that into actual USD, and you can spend the money, right? And then it will incur some interest for you, right? And when you have the money, and when it's going up, you can actually give, let's say, 11,000 or like 10,500, and say, hey, this is USDT that I took from you, and this is the interest. So please take it and give me back my Bitcoin, and it will give you the Bitcoin back. It's exactly like how it works. So this is a very simple example that I gave. There are very, very complex financial instruments that are being built in this. It's called DeFi, decentralized finance. It's a space that even I can't keep up with. There are like too many things happening every day, and like yeah. So this is, of course, the first thing actually that comes is finance. There are a lot of other applications of blockchain where you can actually really use it. But why we have not gone there yet? Because there is a critical thing that was actually missing. So let's say we have Swarm, which is a decentralized like storage system. It has a lot of peers, and they are connected and things like that. It's connected to actually the blockchain for incentivization, because everybody gives some space, right? Some space in in their disk to actually store like somebody else's data. It's like renting out. It's like Airbnb for storage, right? So yeah, so I mean, it's base. It has all its protocols, rules, everything. So if you have, if you store this information for some time, you will actually get some money, and then you can accumulate this money and things like that. It's a way of earning some money, right? So now, usually these kinds of systems, including IPFS, what they give is that they give only two kinds of things. One is you can upload a file, another is you can download that file, right? So now what we need is that if you come from Web2 world, and if you are actually writing a front end, and if you are actually given only file system, right? Hey, no, you don't have database and all these things and all this stuff. You can only store in file system, right? And do whatever you want. So people will be jittery, right? Suddenly, oh my God, I don't have a key value store. Oh my God, I can't do indexing. Oh my God, I can't do search. Oh my God, I can't update. Oh my God, I can't delete a record. All these kinds of stuff will come up, right? So what? Okay, so I can speak about Swarm here. So what I wrote is that I wrote something called Sphere OS, which runs on top of Swarm. It's a very thin layer. Right now, there are efforts actually going into. Like today also I saw there are efforts going into actually convert this into WASM, so that it can be embedded in the front end itself, so that you actually no need to actually run all these systems, right? So this actually writes logic on top of it to create things like mimic a file system and to actually mimic like, a key value store. When I say mimic a file system, imagine Amazon's, like a bucket. What's that? Am I gonna, I forgot the name of that. It's a
S3.
It's a distinct. Sorry, S3. Yes, S3. So S3, right? Yeah, S3, right? So imagine something like that. So you can actually store a lot of stuff in this, right? And then you can have like key value stores, like very simple to level DB, but minus all this compaction that and all these things that level DB do. It does indexing on key, so you can actually go to a key. You can actually go and search the key and get the value. You can add a key value. You can update the value, and you can actually remove the key value also, right? And then I created a document store, something very similar to MongoDB, where people give JSON and say, okay, index on these things, and then it keeps the index, and then you search for it and gives the document. I wanted to build a search store like Elasticsearch or like Apache Solar and all these things, like which is based on Lucene. But yeah, I actually came out of Swarm now, so I'm not doing this actively. So this is a system. This is like a very thin layer, which actually uses the file system, very similar to how things evolved in actually Web2 world. Like 20 years back, you imagine what did we had? We didn't have level DB. We didn't have any key value stores. We didn't have nothing, right? So we had like very expensive things that we have to buy, like Oracle or anything like that. Or I think MySQL was there 20 years back. But yeah, all these things are, that's something that we have to, that enterprises were like, oh, no open source kind of things. 20 years back, nobody touched open source, except people who are working in Linux and Linux related stuff, right? And so I built all these things. Now, when you actually bring a Web2 developer here, now he has all these things. Like now he has like his own browser storage that he can store it locally, or like do things like stuff that he usually does. And he also can store in whatever way he wants, right? And then can actually get the key value systems. It's indexed and all this index, including everything, nothing is stored anywhere in the local file system. It's stored everything in the network, right? Of course, unless you pin it, right? So which will actually cost you. Yeah, so this is the stuff. And then when a normal Web2 guys, believe me, the guys have built so many apps on top of it, right? It actually started with, I gave in like I think in a hackathon, I actually built something called as Fair Maps, where I took OpenStreetMap of like Switzerland and indexed it in key value store, and actually use, I think, leaflet or something like that, which shows the map given the thing stuff. And I was actually able to, show maps, right? Now imagine somebody who wants to do decentralized, Uber or something like that, or decentralized Airbnb, whatever it is, right? And he wants to access maps. He doesn't want to go back to Google Maps. He doesn't want to go back to OpenStreetMaps, because all these are like, centralized service and can be censored. But if you actually store it here, it cannot be censored, right? You can access it. It cannot be, literally cannot be censored, right? So any government who is saying that we will censor, we will, we will block Bitcoin, or we will block Ethereum, are just either innocent or they are like stupid guys, right? So yeah, so this is how it is. This is how things are there. People are writing a lot of dApps over this, and I think in IPFS there is one thing similar to like this is called OrbitDB. They use a different kind of thing to actually do. They use something called CRDTs, to communicate across this layer and then find out the information from IPFS and give it. And if you are using IPFS, you have to use Filecoin, which is their incentivization network, and all all this kind of stuff, right? It depends on what you are using it, right? Okay. So is it okay? Okay until now?
One
Do I have
question.
time? I think we have exceeded the time. I'm really sorry. I didn't look at the time.
I have a question, if you don't mind.
Oh, please go ahead. Go ahead. I'm open for questions. I can speak for another 1 hour, so I don't have anything.
Okay, so you talked about in essence, the fact that there is decentralization means that it cannot be censored, right? Recently, the European Commission published standards on decentralized digital identifiers, DIDs. So in that context, is censorship likely to happen at the identity level rather than across the system?
Okay, so so there are lot of research that went into identity, right? So what's an identity in a decentralized system? In a decentralized system, an identity is actually it's not tied to one person. It's actually tied to one address, right? It's like an Ethereum address, right? So you can actually generate an address. You can install MetaMask, and then it will create an address for you, right? So as long as you have the control of the private key of the address, nobody in the world can, and like if you are using that to encrypt your data, nobody in the world can actually decrypt the data. Even if the government knows that this is your identity, this is your public address, but if they don't know your private keys, they can't do anything.
Zahoor,
They can't say.
I understand what you're saying, but my question was not about decryption of the data. My question was more specifically about censorship of the identity from participating in the process, right? So if you are saying that it is tied to an address, I assume an IP address, IPv4, IPv6, then what kind of address is it tied to?
See, I mean, in any kind of blockchain system, you generate an actually address, which is nothing but a private and public key pair, right? It's like your
it's like a 256-bit key
GPG.
Yeah.
Yes, right.
Unique
so
to...
it's like your older GPG signatures, where you say this is my public address, and people can know that yes, exactly, I sent this message, but yeah, nobody else can imitate me, right? Because only I have the private key of that, right? So
okay,
it's that address. So you don't know where that address lies, and actually, without modifying the protocol of the entire software, all of the software, right? Because everybody is running it, right? So let's say tomorrow I actually do a GitHub fork, and I say I take Ethereum code, and then I actually put some censorship stuff in that. Nobody's going to use it, right? It's like that, right? So so if you ask, let's say yeah, please give me like it's like actually using like centralized exchanges, right? So it's not your key, it's not your money. So if you believe centralized exchanges, keep your money in centralized exchanges. Centralized exchanges can be subjected to hack, or like somebody can swindle the money and can pull the carpet and run off, right?
Okay.
But if you keep it in like your own private wallet and only you know the private key, nobody can take the money from you. Right.
But then,
so but yeah, I'm coming to your point. So if a government says I'm going to create identity, I would want to go actually deeper and see like what kind of identity. Do they want to keep the private key also with them? Do you want to do all these things? I think nobody will use that.
okay,
Right.
so
So yeah,
let's evolve the question a bit. So if you then say, for example, we deploy this blockchain in the metaverse, right? And you're looking to do a transaction such as sell digital real estate, a real estate in the metaverse, not physical real estate, where the individual could potentially be using different avatars on the same identity. How do you ensure that there is trust that enables this transaction? If
see, I
if
can.
everything
Okay.
is going to be
Okay.
confidential, as you're saying.
Okay. So you have to unlearn a lot of things when you come to Web3. So first of all, there is no identity. There's identity like as we know in Web2, right? I mean, in actually Web2, I say, okay, my email is blah 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 @gmail.in, and I give my telephone number, my house address, my everything to them, and they know me very well, right? So they can say this is an individual, and this is another individual. You can create like today you can create like multiple Gmail accounts and all these things, but there are still way to find out that you are the same guy, or you are at least using the same computer, or you are trying to do all these kinds of stuff. All these things are associated with one person. They can actually easily trace you down. But here in a blockchain world, and actually address, like there is no concept of identity. There is only concept of address, right? So I can create like 50,000 addresses, and I can have 50,000 avatars, and go and do like business between my avatar itself, right? That's up to you, right? So there is no guarantee that it is one person,
Right.
right?
So
Yes, please.
going to the essence of the question, if you have 50,000 avatars, and how does that foster trust? Because the essence of blockchain was to foster trust, right?
See, actually trust, okay, so you have to look at it slightly differently. The trust is given in the transaction.
Can I answer that? Actually, that's okay.
Yeah.
So
Okay.
Roland, my point of view on this is blockchain is meant to work in a trustless world, in a world where you don't trust each other, but can still execute transactions with each other. That is the essence of it. Not that it allows you to transact in a situation where you don't know the other party, right? And you don't even care to know the other party, but the system still works.
Exactly. It's because you have put the entire business logic in the chain, and you can actually look at the smart contract and then say, yeah, I believe it. Okay, this is the smart contract. Let's say that I am like a guy. I'm going to give a service. I want a service, and there is like I build a DApp where people can ask for service, and then like somebody can do some service or something like that, right? Let's say I say, okay, I will give $10 for translating my English into something or whatever it is, right? Let's say somebody comes in and he says, okay, I can do this. So he translates it, and then okay, so the guy who's actually translating will see, okay, how do I know whether this guy will give the money after I translate? He doesn't believe the guy. He believes the code, because in the code, the money is actually got from you before you actually start the service, and it is actually logged, right?
It is
So
held in escrow.
yeah, it will head in some sort of escrow, right? I mean, you
Got
can
it.
build whatever you want, logic, right? So that you don't unlock it, right? So and on the other side, how do you know that whether this guy will actually do? So then you can say that, okay, anybody entering my system has to pay some sort of deposit or something like that, right? So that if he's not actually like interacting with the system, or if he's not able to actually deliver on this quality, or like whatever it is, right? So like he will have some slashings. That's the theory, right? That's actually the logic that you have to think about. That's actually the game theory, right? So you actually encode this entire logic in some sort of like a language that we call a smart contract, and then you put it in the chain. So actually party A will not believe party B, it just believes the chain, and party B does not believe party A, party B just believes the chain. So everybody believes the chain. So the chain is actually so important. It's very clear that once it is there, and it is there. Let's say I write very simple program where if I transfer actually money to you, you will get the money only after 3 days. Let's say, I mean, it's a very simple and stupid contract. So now I actually transfer the money. So the money goes and sits in the smart contract. So you know that in 3 days you will get it, guaranteed, 100%, whatever happens, right? Because the smart contract after 3 days will just unlock the money, and then you can go and withdraw the money, right? So
Got it.
this is how it works, right? So the entire thing is not, I mean, it's not, I mean, I don't trust anything except the code. The code is in the chain, and chain is immutable, and it is very hard. I mean, depending upon the blockchain, of course, very hard to, you know, to go unmute something, right? It will take enormous amount of either CPU, or economically it's not feasible. If you take Ethereum 2.0, it's going from proof of work to proof of stake, where you have this. I mean, in Ethereum it's only incentivization, right? Miner gets incentivized if he actually proposes a block, and the block gets added to the chain, right? But in Ethereum 2.0, when you have like proof of stake system, so you don't do all this thing, what you call magic algorithms, and then waste CPU cycles and energy and burn carbon. Instead, what you do is that you actually ask them to pay 32 ETH deposit to do validation. And if you do anything wrong, that can be proved by somebody else cryptographically that, hey, this guy is saying wrong stuff. And there is like, we have 99, let's say there are like 100 guys, and 99 guys say that, yeah, this is the block. And one guy says, no, this is the block. Then that guy is obviously wrong. So for that, he will be slashed. Slashed means punished. That means some amount of money will be actually deducted from his, this thing, deposit, right? And if and for all the other guys, validators, which are equal, which is something like which is the name something equivalent to what's there in today's miners, right? So it's like it's like actually miners which are there today. So if for all the other 99 validators, one guy will actually propose a block, and that guy will get the money, right? So slowly you will start getting the money if you are actually following the protocol rules properly, And if you don't follow the protocol rules properly, you will be slashed. So there is incentivization and de-incentivization, right? So this is actually the logic that they have taken. So you can think about the logic like this, that, hey, I want to build, let's say, a decentralized Uber. What do I do? Okay, I ask the taxi guy to pay a deposit, like before accepting these things, like before accepting the ride. Let's say the ride is like, $50. He pays like $100 deposit, and then he can accept any rides below $50. Let's say he accepts a ride for $50. The guy who actually wants to pay, he pays also $100 in the escrow. Right after the exchange, after they have gone to the destination, both of them say yes sir, and if they are both saying yes, so like $50 from my escrow will move into actually the driver's wallet, and like he can earn money, right? So if you have some issues with the drivers, and if you don't pay, so you can think of things like, hey, I will give you 3 days time. Within 3 days, you guys resolve. Otherwise, I'm going to slash both of you. Things like that. I'm just saying, cooking up stuff, right? So you have to think about the logic that you can do in a very decentralized way. That's why this is like a culmination of economics, and then distributed systems, and then game theory. Very important, right? Because that's what it is. Because you will have always in internet, you will have bad guys, you will have good guys, and the assumption is that to do anything bad, you have to incur some cost, and most likely that will stop you from actually doing that. If you want to spend all your money in slashing, yeah, you can do that, right? But that's unnecessary, right? Nobody will do that. No certain person will do that. That's the thing, right? That's what we have to really think about. How can I actually put my business logic such that I can do this thing in a decentralized way? Now you don't have a central computer or sitting in Uber, which actually knows where the driver is and where this guy is, and it does all of the things automatically as soon as it is. All this automatic stuff and all these things is like it's actually given back to you, right? So the power is like given back. Think of it like this: instead of 5 years, to let's say elect a president. Let's say if you have the power to actually vote on every decision that the parliament takes, or the Congress takes, or the president takes, if everybody can have a vote, and if they are able to vote, how good this world will be, right? So you can't say that, oh my God, I made a mistake, 5 years gone. Next 5 years, I will select a nice president, right? Instead of that, if I give you this power, right? That's the stuff, right? Now with all those centralized app, you are given the power indefinitely. It's not in 5 years. It's like imperial, this thing, right? They are like kings now, right? It's like very, very difficult to displace these guys unless there is a revolution, unless people actually go and think that I think I read it somewhere that Facebook earns like $18 per user per day using your data. So imagine a guy sitting in Nigeria getting that $18 every day, right? He will be very happy. Nigerian government will be very happy, and all this. It's like that, right? But you don't get that, right? So everybody say, okay, free email, free everything. I can start using it, but it actually uses your attention. It uses your cognitive power. to extract money, right? And that money goes to only Facebook and all the guys to whom he sells it, right? I'm not against Facebook or anybody else. I'm against all centralized applications. Okay.
Any
I hope it answers your question.
Yeah, thank you very much. Thank you, much appreciated.
yeah, any I know folks, we've run quite a bit over, so I know Zahoor's, it's quite late where he is. So any questions, any closing comments or questions? I mean, Zahoor, if there's any other specific area you want to touch on, feel free to.
Me, you're asking me?
Zahoor, I have a quick, just an observation. So based on what Roland was asking a question and all the conversation, if I may say, can I say that the contract and address are the only two things that matters in Web 3.0? And if at all anything, there is a definition of a trust?
See, I mean, yes. See, in some sense, address is like a way to actually enter into the system, is to do some transaction. It can be anything. It can be transferring money. It can be going and actually borrowing money. It can be going and selling a painting. It can be anything, right? So to actually enter into a system and do a transaction, you need an address. And that address is, as I said, it's a key pair, right? It's actually a key pair.
Sure.
You'll only say the public address. You will not say the key, private key, right? You will not say that. And with that, what you do is that you interact with something inside the system, which is immutable, which is actually programmable, right? So I can actually go and write a program tomorrow and say that, hey, this is the program to actually send money to, or let's say a salary to all the employees in my 1,000 people org, for example, right? So I can actually create that, and I can just put it, and then every guy can actually come and look at the smart contract, and like you can encrypt all these things, so it's not visible to everybody. So you could say all these things and then say that, yeah, okay, I can be very sure that at the start of the month or start of the every 2 weeks, fortnight, I'm going to get my stuff, right? I'm going to get my thing, right? So it's like that. So you have like a way to enter into system, and you have the system itself, which is actually trustless, right? That means you don't have to trust anybody except the code. The code is the law here, right? So if you want to, let's say there are actually, you can go and search. There are lots of applications. I can give example. So there are applications which actually convert the like cryptocurrency, like from Ethereum to Bitcoin, Bitcoin to Ethereum, and things like that, right? So they do that in a like decentralized fashion. What you do is that, let's say if you have a Bitcoin in your listing, like you go to that system and then say, hey, I have Bitcoin. I have I need equivalent of ETH, right? The system will immediately give you, right? So, and you can be very sure that it will not take away your money and run away, because you can go and look at the code. The code is open. You actually cannot close the code. It's open. Everything. I actually hate when people say that blockchain is so obscure, we can't see anything, and it's like all these things, all this stuff, bullshit. I would say blockchain is the most transparent system that you can build, right? I mean, every transaction done by anybody, you can go and look at the transaction, right? If you know my address, you can actually go and look at all my transactions, right? But it's just that I will not tell my address to you. That's the only thing, right? So let's say if you have, like, as you said, like government identity. So I have to go and declare my address to, let's say, my government. I can still declare it. I can say this is my address, and I can still have 50 more addresses, right? Nobody can stop me. That's why it's very, very difficult to stop anybody from using this, because this is like peer-to-peer. This is you can't put, like, you can't say cease and desist piratebay.com. You cannot say that for Bitcoin. Cease and desist Bitcoin. You cannot say that. No government, nobody can say that, right? Otherwise, by this time, NSA would have actually bought down Bitcoin.
Just one other point worth noting. I don't know what your views are on this, Zahoor, but I think the one thing that people are maybe not sort of talking as much about is over the last 4 or 5 years, particularly as applications on the website have become much more, in some sense, much more sophisticated in what they can do. The compute capacity on end user devices has gone up. You're definitely entering a space where the network can be trustless, and you own the end user device that can do a whole bunch of compute on it, right? Whether it's a phone or whether it's a web browser. So the need to have a lot of backend and servers and data, not shouldn't say servers, backend, traditional backends and databases becomes a lot less, right? In many ways. And you can effectively build pretty powerful applications as long as it has a good front end or a good UI, which can do a lot, and a great and as blockchain improves as well, right? As you move towards things like ETH2. So I think, to your earlier point, yes, maybe what we can do today is somewhat limited, but I think with where the world is going on both those fronts, I think it's going to be very interesting.
Yeah. I think most of the people might be knowing this. I don't know. I don't know the audience. So um, if I am repeating something, if I'm saying something very basic that you already know, please excuse me. Yeah, I think that's all I have. And I just want to, show you that the actual merge, which is the actual merging of ETH1 and ETH2 chain. That's when ETH1 actually changes to proof of stake. It's going to happen very soon, in Q2 itself this year. So after that, it will be like really, really decentralized, right? Now you can say that, you can say at least for Bitcoin that, some Chinese miners and some miners in Iceland are like actually owning everything, and they are doing a lot of stuff, and they are earning, we are not earning, we can't do Bitcoin mining and all these things. But in this one, proof of stake, anybody who has 32 ETH can join, and then they can actually start earning money, right? Passive income. And they can actually take that back, and then they can use that to lend that another. It's all complicated stuff. You can earn much more money than keeping the 32 ETH idle.
Yeah, no, I think
This is going to happen.
that topic requires a deep dive in and of itself.
Yeah, this is like I usually take ETH2 itself as a separate this thing. So I just wanted to actually say to people that this is going to come soon. So yeah, just have a look at what is this merge, and just see how is this. Yeah, I don't want to go much more deeper into that. I think that's all I have. If anybody has any like comments or anything like that, you can DM me, or you can ask Sadiq to forward it to me, and I can answer it.
And this is great.
Okay,
Zahoor. I
but
mean, really appreciate you staying over by so much. If folks have questions, I will forward them on to you. If not, I will be also uploading the video onto YouTube, and if there's anything that comes from that in terms of comments, questions that are relevant, I can forward those as well. But I think in general, this was an amazing session and very, very free flowing and very passionate. So really appreciate it. And Zahoor, a couple of people have asked if they could get a copy of this, the deck. Is that something you'd be open to as well?
deck, I think, okay, I don't have, I think I have given, this
It
is,
doesn't have to be
I
now.
stole this.
Yeah, whatever
Yeah.
you feel comfortable with. No, it doesn't have to be everything.
No, I mean, I can give everything. I don't have any problems. I can give the deck. Maybe the things that I have not talked about, I will remove it and then I will give
Fair
the
enough.
deck until
Fair
this
enough.
point.
Yep, makes
Right?
sense.
So that it makes sense for people to just relate. Yeah, I had that for backup, and like if anybody wants to deep dive into ETH2, I thought I will just use that. But I think this is what essence of Web3 is. Web3 is you have to unlearn too many things from Web2.
Yeah, we can have I think a more targeted audience from the point of view of ETH2, because you're going to go into things like sharding and those kind of things, which I think what you have to have the fundamentals covered before all that starts to
Yeah.
But they don't.
All right, thank you
Okay.
everybody. We'll catch up in next month's mastermind. I thank again everyone for staying over. Appreciate everyone's participation as well. Thank you, Zahoor.
See you. Thank you, Sadiq. Thank you everybody for your patience.
Yeah,
Bye.
so